What if the universe was never truly born? It simply emerged from nothing? Pause on that thought. Let it settle like dust on an ancient mirror. Because before there was light, before there was darkness, before there was even the concept of before, there was nothing. Not the nothing you imagine when you close your eyes. Not the silence of an empty room or the void of deep space. Something far stranger. Something that makes your mind recoil. Because we are creatures built to perceive presence, not absence. We evolved to see the tiger in the grass, not to contemplate the grass that isn't there. Yet here we stand, at the edge of existence itself, asking the question that has haunted philosophers and physicists alike. How did everything come from nothing? The paradox cuts deep. It violates our most fundamental intuition about reality. You cannot get something from nothing, we tell ourselves. The universe cannot bootstrap itself into existence. There must have been a first cause, a prime mover, something that already existed to light the fuse of creation. But what if that intuition is wrong? What if nothing is not what we think it is? Consider for a moment what you mean when you say nothing. You probably imagine empty space, the vacuum between stars, the silence between heartbeats. But empty space is not nothing. Space itself is something. A fabric that can bend and ripple, a medium through which light travels, a stage upon which matter performs its quantum dance. Strip away the space. Strip away time itself. Strip away the laws of physics, the fundamental forces, the quantum fields that permeate reality. What remains? The ancient Greeks wrestled with this demon. Parmenides declared that nothing cannot exist. Tis teat, because to speak of it is to give it existence. How can you point at nothing and call it something? The very act of acknowledging absence creates presence in the mind. Democritus countered that the void must exist for atoms to move through it. Without nothing, there could be no something, no space for things to occupy and transform. They were both right and both wrong, trapped in the limitations of language trying to grasp what cannot be grasped. Fast forward through millennia of meditation and mathematics, through theological arguments and existential dread, to the 20th century, when physics took a scalpel to nothing and discovered it bleeding with possibility. Quantum mechanics revealed that what we call empty space is anything but. The vacuum seethes and writhes with virtual particles, popping in and out of existence so quickly they violate the laws of energy conservation, and get away with it through a loophole in Heisenberg's uncertainty principle. For the briefest instant, the universe permits something to emerge from nothing, as long as it disappears before the cosmic accountant notices. These quantum fluctuations are not theory. They are not speculation. They are measured, observed, undeniable. The vacuum has energy. Nothing has substance, but it goes deeper still. The quantum vacuum is not the absence of fields. It is the lowest energy state of fields that exist everywhere, always, even when they contain no particles. Think of it as an ocean that permeates all reality. What we call particles are merely waves, excitations in this ocean. The universe is not made of things moving through emptiness. It is made of energy dancing through fields that have no off switch, even in its quietest state. The vacuum trembles with potential. This is where philosophy and physics embrace in the dark. The nothing from which everything emerged was not a blank slate. It was not absence in the way we understand absence. It was a state of maximum symmetry, where all possibilities existed in superposition. where the rules that would govern existence had not yet crystallized into the specific form we call our universe. It was pregnant with potential energy, a coiled spring wound by quantum mechanics itself, waiting for something to break the symmetry and release the wound-up tension into the explosion we call the Big Bang. Some physicists propose that our universe is a quantum fluctuation that simply refused to disappear, a random burp in the eternal foam of possibility that inflated into galaxies and consciousness and everything you've ever loved. The odds are astronomically small, yes, but in an infinite multiverse of quantum foam, the improbable becomes inevitable. Somewhere, somehow, nothing becomes unstable. The vacuum tips, symmetry shatters, and suddenly there is time, space, matter, energy, light racing through the darkness it created by coming into being. Others suggest that nothing is mathematically unstable, that a state of absolute nothingness cannot persist, because it contains within itself the seeds of its own violation. Imagine a perfectly balanced equation that equals 0, but the 0 can be expressed as +1 plus -1, as infinite sums and differences that cancel out while still existing. Nothing, they argue, naturally splits into something and anti-something, into matter and antimatter, into positive and negative energy. The universe's total energy might still be 0. We might still, in the deepest sense, be living in nothing. It's just that nothing learned how to arrange itself into patterns complex enough to wonder about their own origin. By the end of this journey, you'll see why nothing might be the most powerful thing that exists. But first, we must venture deeper into the void. We must let go of every assumption about what is real and what is possible, because the universe that emerged from nothing is stranger than you can imagine, and the nothing it emerged from is stranger still. The question is not whether something can come from nothing. The question is whether anything else could have happened, whether existence itself is the universe's way of resolving a paradox that cannot exist, and therefore must. The void awaits, and it is not empty. In quantum physics, nothing can create something, and does so constantly. This is not metaphor. This is not philosophy dressed in scientific language. This is measured, repeatable, experimentally verified reality. The nothing that physicists study in laboratories is not the nothing you imagine. It is not peaceful. It is not still. It is not absent. It is a roiling, seething, churning field of energy that refuses to sit quietly in the corner of existence. And once you understand what scientists mean when they say nothing, you will never look at empty space the same way again. Let's begin with the quantum vacuum. Strip away everything from a region of space. Remove every atom, every photon, every particle you can name. Cool it to absolute 0, so thermal motion stops. Shield it from every force and field you can imagine. You have created, by any classical definition, nothing, a perfect void. But quantum mechanics laughs at your efforts, because even here, in this purest emptiness you can engineer, the universe refuses to be truly empty. The reason traces back to one of the most profound principles in modern physics, Heisenberg's uncertainty principle. You've heard of it, perhaps. In its popular form, you cannot simultaneously know both the position and momentum of a particle with perfect precision. But the uncertainty principle cuts deeper than that. It applies to energy and time as well. And this is where nothing becomes unstable. The principle states that the uncertainty in energy multiplied by the uncertainty in time must be greater than or equal to Planck's constant divided by 4 pi. In plain language, this means that for extremely brief periods of time, the universe's accounting system becomes fuzzy. Energy can fluctuate wildly as long as it settles back down quickly enough. The shorter the time interval, the larger the permitted energy fluctuation. And here's the kicker. There is no lower limit on the time interval, which means there is no upper limit on the energy fluctuation. So even in your perfect vacuum, particles can and do spontaneously appear. An electron and its antimatter twin, a positron, can burst into existence from absolutely nothing, live their brief, impossible lives, and annihilate each other before the universe's books need to balance. These are called virtual particles, and they are not hypothetical. They are not mathematical conveniences. They are real enough to have measurable effects on the physical world. How do we know? Because we've seen their fingerprints. In 1948, Dutch physicist Hendrik Casimir predicted that if you place 2 uncharged metal plates extremely close together in a vacuum, they should attract each other. Not because of gravity or electromagnetism, but because of nothing. The plates restrict which virtual particles can appear in the gap between them. Only those with wavelengths small enough to fit can pop into existence there. Outside the plates, virtual particles of all wavelengths bubble up freely. This creates a pressure imbalance. The vacuum outside pushes harder than the vacuum inside, and the plates move together, pushed by the force of nothing itself. Casimir's prediction was confirmed. The effect is tiny but measurable. Engineers now have to account for it when designing nanoscale devices. Nothing has mechanical force. Emptiness has pressure. The vacuum is not empty. But it goes further. Every quantum field that exists in the universe has a lowest energy state, called the ground state or vacuum state. And here's the disturbing part. That lowest energy state is not zero. It cannot be zero because of the uncertainty principle. Even when a field has no particles in it, it still has energy. This is called zero-point energy, the energy that remains even at absolute zero, even in perfect emptiness, because quantum mechanics forbids perfect stillness. Now multiply this across all the quantum fields that permeate space. The electromagnetic field, the electron field, the quark fields, the Higgs field. Every field in the standard model of particle physics has zero-point energy. Add them all up across every point in space, and you get something deeply troubling. The energy density of the vacuum should be infinite, or at the very least astronomically large. Here's where the paradox becomes visceral. Every cubic centimeter of empty space contains more energy than all the stars in the observable universe. That's what the mathematics of quantum field theory predicts when you calculate the energy of the vacuum. It's called the vacuum catastrophe or the cosmological constant problem, and it is one of the most embarrassing failures in theoretical physics. Because if that much energy actually existed in every cubic centimeter, the universe would have torn itself apart in the first fraction of a second after the Big Bang. Space would expand so rapidly that atoms could never form. Yet here we are. Something is canceling out that energy. Some mechanism we don't understand is driving the vacuum energy density down to a value so close to zero that the universe can exist. But not exactly zero. Never exactly zero. We know this because we've measured the expansion of the universe, and it's accelerating. Something is pushing space apart against the pull of gravity. We call it dark energy, and it behaves exactly like vacuum energy. A constant energy density in every cubic centimeter of space that doesn't dilute as the universe expands. It's as if the vacuum has a slight positive pressure, a faint tendency to push things apart. The energy density is minuscule compared to what quantum field theory predicts, but it's not zero. Nothing has weight. Emptiness has momentum. But what if that energy never disappeared? What if it's still there, hidden in some way we don't yet understand? And the Big Bang wasn't an explosion from nothing. It was a release from everything that was already there. This brings us to spontaneous symmetry breaking, one of the most elegant and unsettling concepts in modern physics. Imagine a pencil balanced perfectly on its tip. In principle, it has perfect symmetry. It could fall in any direction. But that state is unstable. The slightest perturbation, even a quantum fluctuation, will cause it to fall in some specific direction, breaking the symmetry. The pencil is the same, but its relationship to space has changed. The early universe may have existed in a state of perfect symmetry, where all forces were unified, where space had no preferred direction, where the laws of physics were simpler, but the vacuum energy was enormous. This state was like the balanced pencil, perfectly symmetric but unstable. And then something caused it to fall. The symmetry broke. The unified forces split into the four fundamental forces we know today. The Higgs field condensed out of the vacuum, giving particles mass. And in the process, the vacuum energy that was tied up in that symmetric state was released. This is inflation theory, and it suggests that the Big Bang wasn't the beginning of everything. It was a phase transition. Like water freezing into ice, the universe transitioned from a high-energy symmetric state to a lower-energy broken symmetry state. The energy difference drove an exponential expansion, blowing up a tiny quantum fluctuation to cosmic scales in a fraction of a second. The universe we see is the frozen remnant of a nothing that collapsed into something. Think of it this way. Imagine the universe as a field of energy, like a landscape of hills and valleys. In the early state, the universe sat at the top of a hill, a false vacuum, as physicists call it. This position was symmetric but unstable, like a ball balanced on a peak. Then the universe rolled down into a valley, a true vacuum, a state of lower energy. The energy it lost in rolling down became the matter and radiation of the Big Bang. But even at the bottom of the valley, even in this true vacuum we call empty space, the energy is not zero. It's just lower than it was before. And here's the truly unsettling possibility. We might not be at the bottom. Our vacuum might be metastable, like supercooled water that hasn't frozen yet. Somewhere in the universe, a quantum fluctuation might trigger another phase transition. A bubble of true vacuum might nucleate and expand at the speed of light, converting our current vacuum into something else, something lower in energy. Inside that bubble, the laws of physics would be different. Atoms might not be stable. Chemistry might not work. Life would be impossible. This is called vacuum decay. And if it's happening, we wouldn't see it coming. The edge of the bubble would hit us at light speed, rewriting the rules of reality before we could even register the change. But back to nothing. Because what all of this reveals is that nothing is not a state. It's a process. It's not absence, it's potential. The quantum vacuum is not empty space. It's the lowest energy configuration of fields that permeate all of reality. And those fields are never truly still. They fluctuate. They interact. They give rise to forces and particles, and all the complexity we call existence. When physicists calculate what happens in particle accelerators, they must account for these virtual particles. When an electron scatters off another electron, it's not a simple billiard ball collision. Virtual photons are constantly being exchanged between them. Virtual electron-positron pairs are popping in and out of existence in the space between them, screening their charges, affecting the interaction. The vacuum is not a passive background. It's an active participant in every physical process. This is quantum field theory, the most successful scientific theory ever devised. It predicts the magnetic moment of the electron to 11 decimal places. It describes the behavior of fundamental particles with stunning accuracy. And at its heart is this strange truth. Particles are not fundamental. Fields are fundamental. Particles are just excitations in those fields. And those fields exist everywhere, always, even in nothing. So when we ask where the universe came from, we must first ask, what is the universe made of? And the answer is, fields in various states of excitation. The vacuum is the ground state of all fields. Matter is the excited state. You are a pattern of excitation in the quantum fields that fill all space. And those fields exist even when they're not excited. They exist in nothing. Now consider the implications. If virtual particles can appear from nothing and disappear back into nothing, and if there's no upper limit to how much energy can be borrowed as long as it's paid back quickly enough, then why can't an entire universe appear? What if the Big Bang was just the largest virtual particle event in history? A quantum fluctuation that borrowed enough energy to create space-time itself. And that debt hasn't come due yet, because the universe is still expanding, still evolving, still figuring out how to balance the books. Some physicists argue that the total energy of the universe might actually be zero. The positive energy in matter and radiation is exactly cancelled by the negative gravitational potential energy. If you add up everything, you get nothing. The universe is a free lunch, not because energy appeared from nowhere, but because positive and negative energy appeared together, and they still sum to zero. Nothing split itself into something and anti-something, into matter and the gravitational field that will eventually pull it back together. The universe is just a very elaborate way for nothing to remain nothing while appearing to be something. Others point to the nature of time itself. In quantum mechanics, particles can tunnel through energy barriers that classical physics says they cannot cross. They can borrow energy to get over the barrier and pay it back on the other side. But what if there is no before the universe? What if time itself began with the Big Bang? Then there's no need to pay back the energy because there's no earlier time to return it to. The universe didn't borrow energy from nothing. It defined what energy means in the first place. The quantum vacuum is not the absence of things. It's the presence of everything in potential form. Every possible particle, every possible interaction exists there as a superposition of possibilities, waiting for something to collapse the wave function and make one of those possibilities real. Nothing is the sum of all possibilities. Existence is what happens when one of those possibilities actualizes, and still the vacuum seethes. Still the quantum foam bubbles. Still virtual particles wink in and out of existence in every cubic centimeter of space, in every Planck time interval, in a dance so frenzied and fundamental that reality itself emerges from it like a pattern in chaos. Nothing is not stable. Nothing is not inert. Nothing is the most active, most energetic, most pregnant with possibility state that physics has ever discovered. And from this, nothing. Everything we know emerged not as a miracle, but as a mathematical inevitability. The emptiness between your atoms is not empty. The vacuum of space is not a vacuum. And the nothing from which the universe came was never truly nothing at all. It was everything waiting to happen, compressed into a single quantum state that could not remain stable, that had to break, that had to become. Every philosopher tried to describe nothing, and in doing so, created something. This is the ancient trap, the paradox that has ensnared every mind that dared to contemplate the void. To think about nothing is to give it form in consciousness. To speak of absence is to make it present. To define what does not exist is to grant it existence, at least as a concept, at least as a pattern of neurons firing in the darkness behind your eyes. The philosophers knew this. They circled it like hunters around a fire, knowing that the moment they named the darkness, they would lose it. 2,500 years ago, in the Greek colonies of southern Italy, a philosopher named Parmenides declared war on nothing. His logic was ruthless and beautiful. Nothing cannot exist, he argued, because to exist is to be something. If you say nothing exists, you create a contradiction. You've claimed that something which is not can somehow be. Therefore, nothing is impossible. Only being is. The void is an illusion, a trick of language. What is. What is not cannot be spoken of, cannot be thought of. For to think is to think of something. His student Zeno defended this position with paradoxes that still make philosophy students wince. If you want to cross a room, you must first cross half the distance. But before that, you must cross half of that half. And before that, half again. An infinite regression of halfway points stretches before you. Motion becomes impossible. Change becomes illusion. The void between positions cannot exist because there is no space between what is. Being is continuous, unbroken, eternal. The universe is a solid block of existence with no room for nothing, no gaps where being is not. But across the philosophical battlefield, another voice rang out. Democritus, the laughing philosopher, saw things differently. He proposed that reality is made of atoms, tiny, indivisible particles of being, moving through void. And the void had to exist, he argued, because without it, how could atoms move? How could anything change? The void is not nothing in the sense Parmenides meant. It is the space between things, the stage upon which being performs its transformations. Without the void, all would be compressed into a single point of frozen existence. Nothing, in this view, is necessary for something to be something rather than everything. They were both groping at a truth that would take millennia to formalize. Parmenides was right that being is primary, that you cannot have pure nothingness, that existence is woven into the fabric of reality in ways that make true absence impossible. Democritus was right that the void is necessary, that space itself is a thing, that emptiness has structure and function. They were describing different aspects of what we now call the quantum vacuum, a field that is never truly absent, but can be in a state of minimal excitation. Aristotle, ever the systematizer, tried to reconcile these views. He concluded that nature abhors a vacuum, horror vacui. The void cannot exist in the physical world because being rushes in to fill it. Drop a stone in water and the water flows around it instantly. Put two surfaces together and they stick because the vacuum between them would be intolerable to nature. For 2,000 years, this idea dominated Western thought. Nothing was not just philosophically impossible. It was physically forbidden. Then came the medieval theologians who turned nothing into a creation story. God made the universe ex nihilo, from nothing. But this was not the philosophers' nothing. It was not the physicists' nothing. It was theological nothing, the absolute absence of anything except God himself, who existed outside of space and time and matter. Creation from nothing was not a physical process, but a divine act, a manifestation of will that required no mechanism, no explanation beyond omnipotence. Nothing was the canvas upon which God painted existence, and to ask how something came from nothing was to question the nature of divine power itself. The idea that nothing could give birth to everything was once blasphemy. Now it's physics. The shift began in earnest with the Enlightenment. Descartes, meditating in his famous stove-heated room, tried to doubt everything. Could he doubt his own existence? Only if he first existed to do the doubting. Cogito ergo sum. I think, therefore I am. But what about the external world? What about the void? Descartes concluded that empty space was impossible because space itself was defined by extension. It took up room. A vacuum would be space that contained no extension, a contradiction in terms. Where medieval thinkers forbade the void theologically, Descartes forbade it geometrically. But the experiments began to crack the philosophical certainty. Torricelli created a vacuum above Mercury in a tube. Von Guericke built an air pump and showed that space could indeed be emptied, that nature's horror of the vacuum was not absolute, but merely the pressure of air rushing to fill low-pressure zones. The void became real, tangible, measurable. Philosophy had to retreat in the face of evidence. And then Leibniz asked the question that would echo through the centuries. Why is there something rather than nothing? It was phrased as a theological query. Why did God choose to create rather than not create? But it concealed a deeper puzzle. If nothing is the default state, the simplest state, the state that requires no explanation, then something demands justification. Why this universe? Why any universe? Why not just nothing? For 300 years, this question lived in the realm of metaphysics. Philosophers proposed the principle of sufficient reason. Everything must have a reason for being as it is, and not otherwise. But they could not escape the infinite regress. If A explains B, what explains A? If God explains the universe, what explains God? And if God needs no explanation, why does the universe need one? The question became a koan, a meditation on the limits of human reasoning, a place where logic turned back on itself and devoured its own tail. Then quantum mechanics arrived and changed everything. Suddenly, physicists were talking about things appearing from nothing. Virtual particles, quantum fluctuations, the uncertainty principle that made emptiness unstable. And philosophers watched in amazement as their ancient questions migrated from the seminar room to the laboratory. The void was not just a thought experiment anymore. It was something you could measure, manipulate, probe with instruments. Nothing had become physics. Lawrence Krauss, a theoretical physicist, wrote a book with the audacious title, A Universe from Nothing. His argument was stark. Given the laws of quantum mechanics and general relativity, a universe can and will spontaneously appear from the quantum vacuum. You don't need God. You don't need a first cause. You just need the laws of physics and a vacuum that follows those laws. Nothing is unstable. It will decay into something because the mathematics of quantum field theory says it must. Philosophers howled. That's not nothing, they protested. If you have quantum fields, if you have the laws of physics, if you have space-time itself, you already have something. Krauss was smuggling in a framework, a structure, a set of rules, and calling it nothing. True, nothing would have no laws, no fields, no potential for anything. What Krauss called nothing was just the universe in its minimal state. Krauss fired back. "You're quibbling over definitions. Show me your nothing. Describe it. The moment you say it has no laws, you've imposed a law. The law that there are no laws. The moment you say it has no properties, you've assigned it a property. The property of having no properties. Philosophical nothing is incoherent. Physical nothing is at least well-defined. It's the quantum vacuum, the ground state of all fields, the starting point from which calculation can proceed." The debate exposed a deeper truth. Physics and philosophy were asking different questions in the same words. When philosophers ask, "Why is there something rather than nothing?" they're asking about ultimate origins, about the logical foundation of existence itself. When physicists ask the same question, they're asking about mechanisms, about how one physical state evolves into another. The philosopher wants to know why there are laws at all. The physicist wants to know what the laws predict. Stephen Hawking approached the problem from another angle. In his final book, written with Leonard Mlodinov, he argued that the universe can create itself from nothing because of the laws of gravity. When you have quantum mechanics plus gravity, you get spontaneous creation. The universe doesn't need a creator because the laws themselves are sufficient. And those laws exist. Well, they exist because mathematics exists, because logic exists, because certain equations have solutions, and those solutions include universes like ours. But wait, does mathematics exist if there's nothing to instantiate it? Does 2 plus 2 equal 4 in a void where there are no objects to count? Here, Hawking veered into Platonic territory, the ancient idea that mathematical truths exist independently of physical reality, in some abstract realm of pure form. The universe arose from nothing because the mathematical space of possible universes already existed, and ours happens to be one of the solutions to the equations. Philosophers recognized this move. It was Plato updated with quantum mechanics. The forms became equations. The realm of perfect ideals became the landscape of possible universes in string theory. Nothing gave birth to something because abstract mathematical truth has a kind of existence that precedes physical existence. The universe is not made of matter. It's made of mathematics that matter obeys. Roger Penrose, another giant of theoretical physics, offered yet another vision. Perhaps the universe is cyclical, he suggested. Each Big Bang is preceded by a big crunch, or a state of maximum entropy where time loses meaning. In that state, which Penrose calls the conformal boundary, distinctions between something and nothing blur. The universe doesn't come from nothing. It comes from a previous universe that has expanded so much, become so cold and empty, that it becomes mathematically equivalent to a new hot, dense state. Nothing is just something viewed from a different perspective, a different frame of reference where time and scale have transformed. Watch how the conversation evolved. The ancient Greeks argued about whether the void could exist at all. Medieval theologians made nothing the backdrop for divine creation. Enlightenment thinkers made it a geometric or logical impossibility. 20th century physicists made it a quantum field. 21st century cosmologists are making it a phase transition, a mathematical necessity, a conformal transformation. At each stage, nothing became more complex. more rich with structure, more pregnant with possibility. What started as pure absence accumulated properties: quantum fluctuations, field energy, symmetry breaking, mathematical existence. The void that philosophers declared impossible became the most interesting object in physics. Soon you'll learn how even logic itself might have emerged from the void. Because that's where this line of thought leads. If the universe arose from quantum vacuum, and if quantum mechanics is written in mathematics, and if mathematics is built on logic, then what is logic built on? Where do the rules of reasoning come from? Why does modus ponens work? Why can't contradictions be true? Why is there consistency rather than chaos? Some physicists and philosophers now argue that even logic might be an emergent property, something that arose from the universe rather than something that preceded it. In the earliest moments after the Big Bang, when the temperature was infinite and symmetry was perfect, perhaps even the laws of logic were different. Perhaps contradiction was possible. Perhaps the universe was in a superposition of being and not being simultaneously, and logic crystallized out as the universe cooled, just as the four forces crystallized out from the unified force. This is speculation at the edge of speculation, but it shows how far we've traveled from Parmenides declaring that nothing cannot be. Now, physicists wonder if everything we consider fundamental, space, time, matter, energy, causation, logic itself, might be emergent properties of a more fundamental nothing that obeys rules we haven't discovered yet. The conversation between philosophy and physics continues. Philosophers accuse physicists of redefining nothing to suit their equations. Physicists accuse philosophers of clinging to intuitions that quantum mechanics has rendered obsolete. But they're arguing about the same mystery that humans have always argued about. What is the ground of being? What is the foundation upon which reality rests? And what happens when you dig beneath that foundation? The ancient philosophers thought they could reason their way to the answer. Modern physicists think they can calculate their way to it. Perhaps both are right. Perhaps both are wrong. Perhaps the question itself is malformed, a linguistic artifact that disappears when you formulate it precisely enough. Or perhaps the question is eternal, built into consciousness itself, a necessary feature of any mind that can reflect on its own existence. To be aware is to distinguish self from non-self, being from non-being, something from nothing. And once you've made that distinction, once you've drawn that line in the void, the question, why this side and not that side, becomes inevitable. The candle of human thought flickers in the infinite darkness, and every time we think we've illuminated nothing, we discover we've only revealed another layer of something. The equations form from silence. The concepts crystallize from confusion. And still, the mystery deepens. Philosophy met physics at the edge of the void, and together they peered into it, and the void wrote back in mathematics. Before time existed, the laws of physics were already waiting. Think about that impossibility. Not waiting in time, because there was no time. Not waiting in space, because space hadn't been born. The laws existed in a state that language cannot capture, that consciousness cannot grasp, that mathematics can only approach through abstraction. They were not written anywhere. They were not enforced by anything. They simply were. Eternal truths encoded in the logic of existence itself, ready to govern a universe that had not yet happened. And then, in a moment that was not a moment because moments require time, something shifted. A quantum fluctuation in the vacuum that was not a vacuum. A random twitch in probability space. An instability so small it should have disappeared back into nothing before anything could notice. But it didn't disappear. It grew. And in growing, it became everything. This is not myth. This is not speculation. This is the most successful cosmological model we have. Tested against decades of observations, refined by the sharpest minds in physics, supported by data from satellites and telescopes and particle accelerators. The universe began as a quantum event. A single quantum twitch became all galaxies, all life, all thought. And the beauty and terror of it is that nothing else could have happened. Given the laws of quantum mechanics and the nature of the vacuum, a universe was inevitable. Let's rewind to the instant of that fluctuation. Though instant is the wrong word, and rewind makes no sense when time itself is being created. Imagine instead a state of pure potential, a quantum field in its ground state, trembling with zero-point energy. This field permeates what will become space, but space hasn't stretched out yet. Everything that will become our observable universe, every galaxy, every star, every atom in your body, exists as a point smaller than a proton, smaller than a quark, smaller than any meaningful measure of distance we have words for. In quantum mechanics, fields can tunnel through energy barriers. They can jump from one state to another without passing through the states in between, borrowing energy from the uncertainty principle and paying it back before the universe's bookkeeping catches the theft. And in this primordial state, the field that will become space-time sits at what physicists call a false vacuum, a local minimum in the energy landscape, but not the lowest possible state. It's like a ball balanced in a shallow depression on the side of a hill. Stable, but not fundamentally stable. Metastable. Then comes the fluctuation. Perhaps it was truly random. An irreducible quantum event with no cause, no trigger, no reason. Perhaps it happens constantly, eternally, across an infinite multiverse of possibilities. And we exist in the one branch where it succeeded in growing rather than collapsing. The fluctuation nudges the field. The ball rolls. The vacuum begins its transition to a lower energy state, and inflation begins. This is not the Big Bang as popularly imagined, not an explosion of matter into pre-existing space. This is exponential expansion of space itself, driven by the vacuum energy of the false vacuum as it rolls toward the true vacuum. In a fraction of a second so small, it makes a nanosecond look like an eternity. Somewhere between 10^36 and 10^32 seconds. Depending on which model you trust, the universe doubles in size, then doubles again, and again, and again. Not dozens of times, not hundreds, perhaps 60 or 70 doublings, maybe more. The mathematics gets dizzy trying to count. Each doubling takes the same amount of time, but the effect is exponential. After 10 doublings, space is about 1,000 times larger. After 20 doublings, 1,000,000 times larger. After 60 doublings, the expansion factor is roughly 10^18. A billion. A region smaller than a proton becomes larger than the observable universe in less time than it takes light to cross a nucleus. If you could watch this happen, though you couldn't, because space is expanding faster than light can traverse it, and time is being dragged along for the ride, it would look like the universe was being created from nothing, inflating like a balloon, smooth and homogeneous and nearly perfect. Nearly perfect, but not quite. And those imperfections are why we exist. The quantum field driving inflation is not perfectly smooth. It has quantum fluctuations, tiny variations in energy density that get stretched and amplified by the exponential expansion. Think of it like blowing up a balloon with tiny imperfections in the rubber. As the balloon expands, those imperfections grow. What started as microscopic quantum jitter becomes macroscopic variation. These are the seeds of structure, the primordial density fluctuations that will eventually collapse under gravity to form galaxies and stars and planets. We've measured these fluctuations. The cosmic microwave background radiation, the afterglow of the Big Bang, carries their imprint as tiny temperature variations, 1 part in 100,000. These patterns match exactly what inflation theory predicts. The quantum foam of the first instant of time, stretched to cosmic scales, became the blueprint for everything that would follow. The early universe was a quantum mechanical object, and we live in the classical shadow it cast. But what powers this expansion? What is the field that drives inflation? Physicists call it the inflaton field, a placeholder name for something we've never directly detected. It must have certain properties. It must have potential energy that stays roughly constant as the field rolls, so that the expansion rate remains nearly constant. It must couple to other fields only weakly, or the energy would dissipate before inflation completes. And it must eventually reach the bottom of its potential well and convert its vacuum energy into matter and radiation. That conversion is called reheating, and it's where the Big Bang, as commonly understood, actually begins. During inflation, the universe is cold and empty. All the energy is locked up in the inflaton field itself, in the fabric of space. But when the field reaches its minimum, when it can roll no further, all that energy has to go somewhere. The inflaton field oscillates rapidly around its minimum and decays into ordinary particles. The vacuum energy becomes matter energy. The cold, empty, expanding space fills with a hot, dense soup of particles and radiation. Temperature soars to levels so extreme that atoms cannot form. Particles cannot bind. Even protons and neutrons don't exist yet. Just quarks and gluons and leptons and gauge bosons in a plasma hotter than anything in the current universe. This is where the forces of nature, unified during inflation, begin to separate. This is symmetry breaking, one of the most profound processes in cosmology. During inflation, at the highest energies, all forces were one. Electromagnetism, the weak nuclear force, the strong nuclear force, even gravity. All were aspects of a single unified interaction. Particles were massless. The universe was perfectly symmetric. But symmetries are like the pencil balanced on its point, beautiful, elegant, and fundamentally unstable. As the universe expands and cools, as energy density drops, the symmetry cannot hold. First, gravity separates, peeling away from the unified force somewhere around the Planck energy. We don't know the details because we don't have a quantum theory of gravity, but the separation must happen, or the mathematics breaks. Space-time itself becomes something distinct from the other forces, a stage rather than an actor. Then, as the temperature drops further, the strong nuclear force separates. Quarks feel its pull, binding them together, but leptons, like electrons, do not. The strong force is short-range but powerful, strong enough to overcome the electromagnetic repulsion between protons and hold atomic nuclei together. Its separation creates the distinction between particles that feel the strong force and particles that don't, between quarks and leptons, between particles that will build atomic nuclei and particles that will orbit them. Finally, around a trillionth of a second after the fluctuation that started it all, the electroweak force breaks. The electromagnetic force and the weak nuclear force, once unified, become distinct. And this breaking is driven by one of the most important fields in all of physics, the Higgs field. The Higgs field pervades all space, even today. During the early universe, at high temperatures, it sat at zero, the symmetric state where all particles were massless, and the weak force and electromagnetism were indistinguishable. But as the universe cooled, the Higgs field underwent a phase transition, rolling to a non-zero value. This is like water freezing into ice, except what froze was the fabric of reality itself. The Higgs field condensed out of the vacuum, and in doing so, it broke the symmetry, and particles gained mass. Not all particles. Photons, the particles of light, remain massless because they don't couple to the Higgs field. They zip through space at the cosmic speed limit, eternal travelers. But electrons couple to the Higgs and gain mass. Quarks couple differently and gain different masses. The W and Z bosons, carriers of the weak force, couple strongly and become very massive, which is why the weak force is so short-ranged. Mass is resistance to acceleration, and that resistance comes from interacting with the Higgs field that fills all space. You are massive because the Higgs field caught you. This cascade of symmetry breaking, gravity separating, strong force separating, electroweak breaking, is not separate from the birth of the universe. It is the birth. The universe doesn't emerge from nothing and then develop properties. The emergence itself is the development. Nothing becomes something by acquiring structure, by breaking symmetry, by rolling down energy landscapes and crystallizing into the specific form we call our universe. Other roles, other symmetry breakings, would give other universes with other forces and other particles. We got this one. By the time the universe is a millisecond old, it has cooled enough for quarks to bind into protons and neutrons. By the time it's 3 minutes old, those protons and neutrons fuse into the first atomic nuclei: hydrogen, helium, trace amounts of lithium. But the universe is still too hot for electrons to settle into orbits around nuclei. Any atom that tries to form is immediately blasted apart by high-energy photons. The universe is opaque, filled with a dense fog of plasma that scatters light in every direction. Then, about 380,000 years after the initial fluctuation, the universe cools to 3,000 Kelvin, and the fog lifts. Electrons finally combine with nuclei to form neutral atoms in a process called recombination. Suddenly, photons can travel freely through space. They decouple from matter and stream outward in all directions, carrying with them a snapshot of the universe at that moment. Those photons have been traveling ever since, stretched and cooled by the expansion of space, and they reach us today as the cosmic microwave background, the oldest light in the universe, the echo of the moment when the universe became transparent. We've mapped this light in exquisite detail. We've measured its temperature to 6 decimal places, 2.72548 Kelvin. We've analyzed its fluctuations and found them exactly where inflation predicts they should be. We've tested the theory of cosmic nucleosynthesis and found the abundances of hydrogen and helium match the predictions to stunning precision. The story I'm telling you is not speculation. It is the measured, observed history of the universe, reconstructed from light that has been traveling for nearly 14 billion years to reach our telescopes. But here's where the existential dread creeps back in. What if that fluctuation wasn't the first, or the last? Inflation theory solves many problems in cosmology, but it creates others. If the inflaton field can fluctuate once to create our universe, why not again? And if it happens again, where does it happen? In quantum mechanics, fluctuations never stop. The vacuum is always seething, always probabilistically exploring every possible state. And in eternal inflation theory, once inflation starts, it never completely stops. In some regions, the inflaton field reaches its minimum, and inflation ends, creating a bubble universe like ours. But in other regions, random quantum fluctuations kick the field back up, and inflation continues. Those regions expand exponentially, creating more space where more fluctuations can occur, creating more bubble universes. The result is a fractal multiverse, an infinite tree of bubble universes branching eternally into the future and perhaps stretching eternally into the past. Our universe is one bubble among countless others, each with potentially different values for the fundamental constants, different symmetry breaking patterns, different laws of physics. Most would be sterile, devoid of structure or life. But an infinite number would, by pure chance, have conditions suitable for complexity, for chemistry, for biology, for consciousness. This is the landscape of string theory taken to its logical conclusion. There may be 10 to 500 different ways for the extra dimensions to curl up, each giving a different effective physics in the resulting four-dimensional universe. And eternal inflation populates that landscape, creating every possible universe somewhere, somewhen, in the infinite foam of quantum fluctuations and exponential expansion. If this is true, and we may never know if it's true, because other bubble universes are fundamentally unobservable from within ours, then the question, why is there something rather than nothing, has a new answer. Because nothing is unstable to becoming something. And given eternity, instability becomes inevitability. The quantum fluctuation that birthed our universe wasn't special. It was just one of infinite fluctuations in an infinite field. And we exist in this particular bubble because this particular bubble has the right properties for existence to ask the question. But even if eternal inflation is wrong, even if our universe is the only universe, the story remains astonishing. A quantum event smaller than an atom became a space larger than anything we can see. A random fluctuation in a field became the galaxies and stars and planets. A twitch in probability became conscious observers capable of reconstructing their own origin story and feeling awe at it. And time? What about time? During inflation, proper time nearly stops. The expansion is so rapid that the space-time geometry becomes almost frozen. After inflation, as the universe fills with matter and radiation, time unfolds at the rate we experience. But in the initial fluctuation, in the quantum tunneling event that starts inflation, time itself is fuzzy, smeared out by the uncertainty principle. Some physicists describe the origin as imaginary time, borrowing a term from mathematics where time behaves like a spatial dimension. Stephen Hawking used this to argue that asking what came before the Big Bang is like asking what is north of the North Pole, a grammatically correct question that has no answer because the framework breaks down. Time emerges from timelessness. Space emerges from spacelessness. Matter emerges from energy. Energy emerges from the quantum vacuum. The quantum vacuum emerges from what? From the mathematical structure of quantum field theory? From the logical necessity of certain equations having solutions? From nothing at all. If nothing includes the potential for laws, the circularity is dizzying. The universe creates the conditions for its own existence by existing. The laws of physics permit a universe to arise from nothing, because those laws are instantiated by the universe that arises. It's not a causal chain. It's a self-consistent loop. The universe doesn't need an external cause because it is causally closed, containing within itself all the reasons for its own being. And yet, standing here, 13.8 billion years after that initial quantum twitch, made of atoms forged, in dying stars, animated by electrical signals in a brain that arose from chemistry, that arose from physics, that arose from nothing, we can trace the line backward. We can measure the light from the beginning. We can calculate what the first seconds were like. We can peer into the moment of creation itself and see our own origin written in the mathematics of fields and fluctuations. A single quantum event became everything, not because it was miraculous, but because the laws of physics left it no choice. The vacuum was unstable. The symmetry had to break. The universe had to expand and cool and crystallize into galaxies and stars and planets and people. Given nothing, given laws, given quantum mechanics and fields and fluctuations, this is what happens. This is the inevitable unfolding of possibility into actuality, of potential into presence, of nothing into everything we call home. And somewhere, perhaps, in a region of the multiverse we'll never see, another fluctuation is happening right now. Another universe is being born. Another nothing is becoming something. The quantum field never rests. Inflation never truly ends. The birth of universes is not an event in the past. It's an eternal process, happening always, everywhere, in the infinite foam of quantum possibility. We are one ripple in an infinite ocean, but we are a ripple that knows it's a ripple, that can trace its origin to the quantum foam beneath, that can speak the mathematics of its own creation. And in that knowledge, in that self-awareness, something truly emerges from nothing. Meaning, if the universe can create itself, does it still need a beginning? This question violates everything your intuition tells you about cause and effect. A thing cannot create itself. To create requires existing before the created thing exists. Self-creation is a logical contradiction, a temporal impossibility, a paradox that should collapse under its own weight. And yet, when you apply the mathematics of quantum mechanics and general relativity to the origin of the universe, self-creation is not just possible. It might be inevitable. Welcome to the strangest territory in cosmology, where time loops back on itself, where cause and effect become circular, where the universe pulls itself into existence by its own bootstraps. Here, the clean linear narrative of creation breaks down. The universe doesn't have a beginning in the way you think of beginnings. It doesn't emerge from something else, and it doesn't emerge from nothing in the simple sense. It emerges from itself, contains its own cause, is both the creator and the created, the first mover and the moved. Let's start with the most disorienting possibility: closed time-like curves. In Einstein's general relativity, Space-time is not a fixed stage, but a dynamic fabric that bends and warps in response to matter and energy. And the equations permit something that seems impossible: paths through space-time that loop back on themselves in time as well as space. A closed time-like curve is a trajectory that allows you to travel into your own past, to exist before you existed, to influence the conditions that gave rise to you. Most physicists think such curves are probably impossible in our universe, forbidden by some deeper law we haven't discovered yet. They create causal paradoxes, the grandfather paradox, where you could theoretically prevent your own birth, creating a logical contradiction. But mathematically, they're allowed. And if they exist near the quantum scale, near the Planck length, where space-time itself becomes grainy and uncertain, they might resolve the paradox of cosmic origins. Imagine the universe as a closed time-like curve. Not in the sense that if you travel far enough through space, you return to where you started, though that might also be true, but in the sense that if you trace causation backward far enough, you eventually arrive at the future. The Big Bang is caused by the universe that emerges from it. Time is a loop. The universe creates the conditions for its own creation. There is no external cause because there is no outside the loop. Causation is circular, self-consistent, self-contained. This sounds like word games, like we're playing tricks with tenses and pronouns to avoid the real question. But it's mathematically coherent. In quantum mechanics, particles can influence their own past through what's called retrocausality. The choice you make to measure a particle now can affect what state it was in before you measured it. The universe, as a quantum object in its earliest moments, might exhibit the same behavior at cosmic scale. The boundary condition at the end of time, assuming there is an end, becomes one of the initial conditions at the beginning. Stephen Hawking approached this from a different angle with his no-boundary proposal. Working with James Hartley, Hawking asked, what if the universe has no boundary in time, no edge where it begins? What if asking what came before the Big Bang is like asking, what's south of the South Pole? A meaningless question because you've reached a boundary of the coordinate system itself. The key is imaginary time, a mathematical trick that treats time as if it were a spatial dimension. In normal space-time, time is distinctly different from space. You can move freely in 3 spatial dimensions, but you're dragged inexorably forward in time. But in the quantum gravity regime, at the Planck scale where the universe begins, this distinction blurs. Time becomes imaginary in the mathematical sense, and the 4 dimensions of space-time become more symmetric. In this framework, the early universe is not a point in time, but a region of space-time that smoothly closes on itself, like the surface of a sphere. Just as the Earth's surface has no edge, you can walk in any direction forever and never fall off. The universe's space-time might have no temporal edge. It's finite, but unbounded. The Big Bang is not a moment of creation, but a region of maximum curvature, where time gradually emerges from timelessness as you move away from the origin. Hawking's own words capture it. The boundary condition of the universe is that it has no boundary. There is no need for a first cause because there is no first moment. Time itself is a property that emerges gradually, and asking what caused, the universe is asking what caused time. which is asking what happened before time existed, which is asking a question whose premise invalidates itself. But does this solve the mystery or merely relocate it? The no-boundary proposal requires quantum mechanics and general relativity to be true. It requires a specific wave function for the universe. It requires laws of physics. And where do those come from? Perhaps the universe doesn't exist because of laws. Perhaps it is the laws. This is the radical suggestion that the universe is not a physical thing governed by mathematical laws, but is itself a mathematical structure. Not a thing described by equations, but the equations themselves, instantiated in some sense that transcends the distinction between map and territory. In this view, proposed by cosmologist Max Tegmark among others, physical reality is mathematics. Every consistent mathematical structure exists in some sense, and we find ourselves in one that permits observers because that's the only kind where finding yourself is possible. If this is true, then the question of origins transforms completely. Mathematical truths don't come into being. The Pythagorean theorem was true before the universe existed, will be true after it ends, is true even in universes where triangles never form. Mathematical existence is eternal, necessary, independent of physical instantiation. So if the universe is mathematics, it doesn't need to be created. It exists in the same way that numbers exist, equations exist, logical truths exist, not as things in space and time, but as necessary features of the structure of possibility itself. But this seems to trade one mystery for another. Why should mathematical structures have any physical reality? Why should equations be experienced as matter and energy rather than remaining abstract patterns? What breathes fire into the equations, as Hawking asked, and makes a universe for them to describe? Perhaps no fire is needed. Perhaps the distinction between abstract and concrete is itself an illusion, a leftover from dualistic thinking that separates mind from matter, form from substance, mathematics from physics. The universe doesn't need to be realized. It already is realized by virtue of being mathematically consistent. You are not separate from the mathematics. You are a particular pattern within it, a self-consistent structure of information, a process that the equations describe and thereby bring into being. This borders on mysticism, but it's grounded in physics. Quantum mechanics tells us that particles are not little billiard balls, but probability waves, mathematical functions that describe likelihood of measurement outcomes. And those waves are not in space. Space emerges from relationships between quantum fields. The field is the fundamental reality, and the field is defined by equations, and the equations are instantiated by what? By themselves, by the logical necessity of mathematical consistency. Now layer in eternal inflation, and the picture becomes even stranger. If inflation is eternal, if quantum fluctuations keep triggering new inflationary regions forever, then the multiverse has no beginning. It's eternal into the past as well as the future. Our bubble universe had a beginning, yes, a quantum fluctuation that triggered inflation here. But the larger structure, the inflating meta-space-time in which our bubble formed, has always existed and always will exist. This seems to solve the origin problem by denying there is one. No first cause is needed because there is no first moment. The multiverse is eternal, uncaused, self-perpetuating. It's turtles all the way down, except instead of turtles, It's inflating regions, spawning new inflating regions in an infinite fractal cascade with no bottom. But wait, doesn't this violate thermodynamics? If the universe has existed forever, shouldn't entropy be infinite? Shouldn't everything have decayed to maximum disorder already? This is called the Boltzmann brain problem, and it's deeply disturbing. In an infinitely old universe with random fluctuations, the most likely explanation for your existence is not that you evolved through billions of years of cosmic history, but that you're a random fluctuation. A brain that spontaneously assembled with false memories of a past that never happened. Because fluctuating into existence as a brain with memories is vastly more probable than fluctuating into existence as an entire universe with a consistent history. Unless time doesn't work the way we think. Unless the past is not fixed, but is selected from possibilities by the requirement that it lead to the present. This is the Wheeler-DeWitt equation, the fundamental equation of quantum cosmology, which treats the entire universe as a single quantum state. In this framework, the universe doesn't evolve in time. It exists as a superposition of all possible configurations. And what we experience as time's flow is the unfolding of correlations within that static structure. Think of it like a movie. The film doesn't happen. It exists all at once as a sequence of frames. But when you watch it, you experience it as unfolding, as becoming, as having past and future. The universe might be like that film. All moments exist simultaneously in the Wheeler-DeWitt equation. The Big Bang and the heat-death of the universe are both there, not separated by time, but by configuration space. Time is the order in which conscious observers experience correlations between different parts of the wave function. If this is right, then the universe doesn't create itself in time. It creates itself logically. It's a self-consistent solution to the Wheeler-DeWitt equation, a wave function that satisfies the constraints of quantum mechanics and general relativity simultaneously. There are many possible solutions, many possible universes, and we experience the one we experience because we are patterns within it. Because the wave function describes us as existing in this configuration rather than some other. The universe becomes a mathematical object that solves for its own existence, not through temporal causation but through logical necessity. It exists because its existence is mathematically consistent, and non-existence would be inconsistent. The laws of physics are not constraints imposed from outside, but features of self-consistency, ways that the universe must behave in order to be the thing it is. This is the bootstrap, the strange loop, the Ouroboros eating its own tail. The universe justifies itself. It's the ultimate tautology. Existence exists because existence exists. But it's not empty circularity. It's rich, structured, full of consequences. From the bare fact of self-consistent existence, all the complexity we see emerges. Galaxies, stars, planets, life, consciousness, wonder, all the way up to this moment where you encounter these words and feel the vertigo of understanding that you are the universe explaining itself to itself. But let's push further. What if even existence and non-existence are not opposites, but complementary aspects of the same reality? What if they're related the way matter and antimatter are related, or positive and negative numbers, or yin and yang? What if the universe doesn't exist instead of not existing, but exists and doesn't exist simultaneously, in superposition, and only appears to exist from within the wave function that describes it? This is where quantum cosmology gets truly vertiginous. In quantum mechanics, a particle in superposition is not in one state or the other. It's in both until measured. But the universe as a whole cannot be measured from outside, because there is no outside. So the universe might remain in superposition forever, existing and not existing simultaneously, with only local observers collapsing portions of the wave function into definite states through the act of observation. You exist. That much seems certain, but does the universe exist when you're not looking at it? Does the past exist? Does the future? Or are they quantum possibilities that crystallize into actuality only as consciousness moves through them? Collapsing wave functions, selecting one branch of the multiverse from the infinite tree of possibilities? Some interpretations of quantum mechanics, like the many worlds interpretation, say every possibility is realized. The universe splits every time a quantum measurement occurs, creating branches for every outcome. In one branch, you exist. In another, you don't. In infinite branches, every possible version of you experiences every possible life. And all these branches exist simultaneously, not in physical space, but in the space of possible configurations, what physicists call Hilbert space. If this is true, then asking whether the universe exists is like asking whether the number 3 exists. It's a category error. The universe is not a thing that exists or doesn't exist. It's the totality of all possible configurations, all mathematical structures, all consistent ways for things to be. Some configurations contain observers. Those observers, by virtue of existing, experience their configuration as the universe. But they're just one branch, one pattern, one solution among infinite solutions. The next act reveals what might lie beyond even the concept of existence. Because we're approaching the limits of what language can express, what mathematics can model, what consciousness can grasp. Beyond existence and non-existence lies something that cannot be named, because naming it would reduce it to a concept. And concepts are tools minds use to divide the indivisible, to make manageable what cannot be managed. Perhaps there is no ultimate ground, no final answer, no deepest level. Perhaps it's questions all the way down, each answer spawning new questions, each explanation requiring deeper explanation. Forever. Or perhaps the circle closes. Perhaps when you trace explanation deep enough, you find yourself back at the beginning, having traveled through all of logic and mathematics and physics, only to arrive at the simple fact: something is. And that something is needs no further justification, because there is nowhere further to go. The universe exists because here we are, asking why. And the asking is part of the answer. Consciousness is the universe becoming aware of itself. And that awareness completes the loop. We are the universe's way of justifying its own existence. The self-creating universe is not a theory. It's a recognition that creation is the wrong metaphor. The universe doesn't come from somewhere or happen at some time. It simply is, eternally, necessarily, self-consistently. It's a mathematical structure that contains within itself the rules for its own behavior, the conditions for its own existence, the observers who can contemplate it. It needs no external cause because causation is internal to it. It needs no creator because it creates the concept of creation. And perhaps this is the deepest answer to why there is something rather than nothing. Because something and nothing are not alternatives, but complementary descriptions of the same reality viewed from different perspectives. Nothing, fully understood, contains the potential for everything. Something, fully understood, sums to nothing when you account for all the positive and negative, all the matter and antimatter, all the energy and negative gravitational potential. The universe is nothing in disguise. Existence is a cosmic magic trick, where the magician and the audience are the same entity, forgetting and remembering itself eternally. We are living inside the answer to our own question. The universe doesn't need to be created because it is self-creating. It doesn't need to begin because it contains its own beginning. It doesn't need a cause because it is causally closed. A strange loop of existence feeding back into itself, justifying itself by existing, existing by justifying itself, a self-consistent dream that has no dreamer, because the dream itself is the dreamer. And you are a pattern in that dream. Brief and brilliant, asking questions whose answers lead only to deeper questions, seeking origins that recede infinitely, grasping at nothing and finding everything. Maybe the universe didn't come from nothing. Maybe it is nothing, dreaming itself alive. This is where physics meets its own horizon, where equations dissolve into questions that mathematics cannot answer, where the clean certainty of science gives way to the ancient vertigo of philosophy. We've traced the universe back to its quantum origins, watched it bootstrap itself into existence through fields and fluctuations. But now we must ask, what is the substrate beneath the substrate? What is the ground beneath the ground? If the universe emerged from quantum vacuum, and the quantum vacuum is a state of fields obeying laws, then what are fields made of? What are laws made of? What is the canvas upon which reality is painted? Perhaps the answer is information. Not information in the casual sense. Not data or knowledge or meaning, but information in the fundamental sense that quantum mechanics and thermodynamics have been converging toward. The basic unit of existence, more fundamental than matter or energy, the irreducible currency of reality itself. A bit, a quantum bit, a choice between two possibilities. Yes or no, 1 or 0. Being or not being, John Wheeler, the physicist who coined the term black hole and mentored Richard Feynman, spent his later years obsessed with this idea. He called it from bit. The notion that every physical thing, every it, derives from information, from the answer to yes or no questions, from bits of binary choice. The universe is not made of stuff that obeys mathematical laws. The universe is made of information structured by mathematical relationships. Matter is information. Energy is information. Space-time is information. You are information arranged in a pattern complex enough to process information about itself. Look at black holes, those extreme laboratories where physics breaks down and new truths emerge. Stephen Hawking showed that black holes have entropy, a measure of information or disorder proportional to their surface area, not their volume. This was shocking. Entropy should scale with volume, with the number of particles or states inside. But black holes encode their information on their surfaces, as if three-dimensional reality is a projection from a two-dimensional boundary. This is the holographic principle, and it suggests something profound. Space might be emergent, an illusion created by relationships between bits of information encoded elsewhere. If reality is fundamentally information, then what is nothing? It cannot be the absence of information, because even absence is information. The bit flipped to 0 rather than 1. The answer no rather than yes. Nothing would have to be the state before information itself, before the possibility of binary choice, before yes and no crystallized into distinct alternatives. Nothing would be the undifferentiated potential from which the very concept of distinction emerges. This sounds mystical, but it's grounded in physics. Quantum superposition is exactly this: a state where yes and no haven't separated yet, where the particle is not here or there, but in a fuzzy both and neither until measurement forces a choice. And measurement is interaction, which is information exchange, which is the universe asking itself a question and collapsing possibilities into actualities. Reality is the ongoing process of information revealing itself to itself. But who or what is asking the questions? Who collapses the wave function? This is the measurement problem, quantum mechanics' deepest mystery, and it points toward something unsettling. Consciousness. Not necessarily human consciousness, not necessarily biological consciousness, but something that observes, that registers, that transforms potential into actual. In the Copenhagen interpretation of quantum mechanics, the act of measurement, which requires a conscious observer in some formulations, is what collapses the wave function and makes reality definite. Before observation, there are only probabilities. After observation, there is fact. And observation requires something that can observe. This led physicist Eugene Wigner to propose that consciousness itself might be fundamental, not emergent from matter, but prior to it. The universe doesn't create minds. Minds, or mind, or something like awareness, is woven into the fabric of reality from the beginning. This is panpsychism, the ancient and recently revived idea that consciousness is not a quirk of complex neural systems, but a basic feature of existence itself, present in some form at every level, from electrons to galaxies. Consider how strange consciousness is. You are matter arranged in a particular way, atoms obeying physical laws, electrochemical signals propagating through neural networks. But you are also subjective experience, the redness of red, the pain of pain, the what it is like to be you that has no physical description. Science can map brain states to mental states, can predict behavior from neural activity, but it cannot explain why there is experience at all. Why doesn't the information processing happen in the dark? Why is there someone home inside your skull? This is called the hard problem of consciousness, and it has resisted every attempt at purely materialist explanation. Some philosophers argue that consciousness cannot emerge from unconscious matter, any more than wetness can emerge from dry things. If consciousness exists now, it must have existed always, in some form, woven into the quantum fabric, waiting to complexify and organize and reflect upon itself through biological systems like brains. If this is true, if awareness is fundamental, then nothing might not be the absence of consciousness but its purest form. Undifferentiated awareness before it splits into subject and object, observer and observed, self and world. Nothing as the plenum of potential experience, the unified field of consciousness before it, fragments into individual minds experiencing individual realities. This is where Eastern philosophy and quantum physics have their strangest resonance. The Buddhist concept of sunyata, emptiness or voidness, is not mere absence, but the pregnant void from which all phenomena arise. It's described as luminous, aware, the ground of being that is no thing in particular and therefore capable of being all things. The Hindu concept of Brahman is similar, the undifferentiated consciousness that dreams the universe into being, that forgets itself to become many. that plays at being separate to experience relationship and love and loss. Are these metaphors, or are they glimpses of something real? When physicists describe the quantum vacuum as a field of pure potential, when they speak of wave functions containing all possibilities until collapsed by observation, when they suggest consciousness might play a role in making reality definite, are they rediscovering in equations what mystics intuited in meditation? Perhaps. Or perhaps we're reaching the limits of what can be said, where different vocabularies, mathematical, mystical, philosophical, point toward the same ineffable truth without ever quite capturing it. Now consider the simulation hypothesis. What if this entire reality is a computation, code running on some substrate we can't perceive? What if the universe is a simulation created by advanced beings, or by a quantum computer, or by some form of intelligence we can't imagine? The physicist Nick Bostrom showed that if certain assumptions hold, if civilizations develop the capacity to run detailed simulations, if they choose to run many such simulations, if consciousness can be instantiated in software, then statistically, we are almost certainly living in a simulation rather than base reality. This sounds like science fiction, but it has deep implications for the question of nothing. If reality is a simulation, what does that make the code? Nothing or everything? Is information more real than matter? Or are they the same thing viewed at different levels of abstraction? And what is the substrate on which the code runs? If our universe is simulated, what is the simulator made of? Information all the way down? Or something else? Something we have no concepts for because we've only ever experienced the simulation. Turtles again. Explanations that require explanations. Unless the simulation is self-executing, code that runs itself without hardware, mathematics instantiated without a computer, because mathematical truths need no instantiation. They simply are, necessarily, eternally. Then the simulator and the simulated collapse into the same thing. The universe is both the code and the execution of the code, the program and the computer, self-creating not through time, but through logical structure. This converges with the idea that reality is mathematics. If the universe is a mathematical structure, and conscious observers are patterns within that structure, then the distinction between simulation and reality dissolves. You can't be simulated if there's no base reality separate from the simulation. You can only be a pattern of information that experiences itself, that processes its own state, that is aware because awareness is what information does when it reaches sufficient complexity and self-reference. And nothing? Nothing becomes the set of all possible mathematical structures, the infinite library of every consistent equation and its solutions. Our universe is one book in that library. Other universes are other books. And the library itself needs no explanation because mathematics is necessary truth, existing outside space and time prior to physics, independent of instantiation. You can destroy every physical book, but the Pythagorean theorem remains true. You can end the universe, but the equations that describe it remain valid in some abstract sense. But does abstract existence mean anything? Does a mathematical structure that is never instantiated, never observed, never experienced, does it exist in any meaningful sense? Or does existence require instantiation, require observation, require the presence of conscious beings to collapse possibility into actuality? This is where the circle closes, where all the interpretations we've explored converge on the same strange truth. Nothing and something are not opposites, but interdependent. Nothing is the potential for something. Something is the actualization of nothing. And the boundary between them is consciousness, or observation, or information processing, or whatever you want to call the process by which possibilities become facts. The quantum vacuum is not empty because emptiness is unstable. It's filled with potential, virtual particles, quantum fluctuations, all possible states in superposition. But that's not chaos. That's maximum order, perfect symmetry, all possibilities existing equally with none preferred. It's only when symmetry breaks, when observation happens, when information crystallizes, that the richness of specific reality emerges. Nothing is not the opposite of everything. Nothing is everything that hasn't chosen what to be yet. It's the undifferentiated source, the plenum of potential, the infinite possibility space from which finite actualities emerge through the process of what? Choice? Observation? Collapse? Dreaming? Maybe the universe is nothing's dream of being something. Maybe consciousness is nothing's way of experiencing itself. Maybe you are nothing's strategy for understanding what it means to exist, to love, to suffer, to wonder, to ask questions about your own origin and discover that the questioner and the questioned are the same. The final act will reveal the true meaning of nothing and why it might outlast the universe itself. Because if nothing is pure potential, if it's the ground from which all realities emerge and to which all realities return, then it's more fundamental than any particular universe. Our universe will end, either in heat death, the gradual cooling and dispersal of all energy until nothing can happen anymore, or in a big crunch, collapsing back to a singularity, or in vacuum decay, a quantum transition that rewrites the laws of physics. But nothing persists. The quantum vacuum that gave birth to our universe remains, ready to birth others. The information substrate that encodes reality remains, capable of encoding different realities. The consciousness that observes existence remains, capable of observing different existences. Nothing is eternal in a way that something can never be. Specific things come and go. Universes rise and fall. But the potential for things, the space of possibilities, the nothing from which somethings emerge, that has no beginning and no end. It's not in time because time emerges from it. It's not in space because space is one of its products. It's not nothing in the sense of empty void, but nothing in the sense of undifferentiated fullness, zero that contains infinite positive and negative, silence that contains all possible sounds, darkness that contains all potential light, and here, at the edge of what can be thought or said, we find ourselves back at the beginning. What is nothing? It's not the absence of something. It's the presence of everything in potential form. It's not lack but possibility, not void but plenum, not death but the womb from which all existence springs, and the tomb to which all existence returns, and the eternal present that holds both simultaneously. If the universe is information, then nothing is the hard drive before data is written. If the universe is mathematics, then nothing is the space of all possible equations. If the universe is consciousness experiencing itself, then nothing is consciousness before it splits into experiencer and experienced. If the universe is a simulation, then nothing is the capability to run code before any particular code is executed. In every case, nothing is not less than something. It's more. It's the infinite containing the finite, the eternal containing the temporal, the necessary containing the contingent. Something is limited, specific, particular. Nothing is unlimited, universal, total. something dies. Nothing cannot die because it was never born. Something changes. Nothing cannot change because it already is all possible changes simultaneously. We fear nothing because we think it means annihilation. But perhaps annihilation is just the return to potential, the dissolution of the specific into the general, the many becoming one again. Death is not falling into nothing. Death is recognizing you were always nothing, just briefly arranged in a pattern complex enough to forget it, to believe in separation, to experience the illusion of being a separate self in a world of separate things, and perhaps awakening, whether through death or enlightenment or understanding, is remembering that you are nothing playing at being something, emptiness dreaming itself into form. The void that got curious about what it would be like to not be void, and so became galaxies and stars and planets and brains and thoughts and the feeling of wind on skin and the taste of bread and the ache of longing and the peace of understanding. You are nothing. I am nothing. This moment is nothing. But it's nothing that has momentarily forgotten itself, that has crystallized into specificity, that dances in the space between existence and non-existence, that asks questions about its own nature and finds only deeper questions, only paradoxes, only the recognition that the questioner and the questioned are both masks worn by the same faceless nothing. The universe came from nothing, not because nothing is the absence of everything, but because nothing is the potential for everything, and potential inevitably actualizes because that's what potential means. Nothing could not remain nothing because nothing is pregnant with something, is something in disguise, is something that has not yet chosen its form. And when the universe ends, when all stars burn out and all particles decay, and space-time itself perhaps dissolves back into quantum foam, nothing remains, not as absence but as presence, not as ending but as beginning, not as death but as the infinite potential for new life, new forms, new universes, new ways of being. Nothing is the alpha and omega, the ground and the goal, the source and the destination. It's what you came from and what you'll return to and what you've always been beneath the costume of selfhood. And far from being terrible, far from being empty, it's the fullest thing there is. So full it appears empty, so bright it appears dark, so present it appears absent, so everything it appears nothing. This is the meta-realm beyond existence, the domain where all our categories break down and all our language fails. We've reached the limit of what physics can tell us and the beginning of what only silence can convey. Beyond this point lie questions that have no answers because the asking is the answer, paradoxes that resolve only when you stop trying to resolve them, truths that can only be experienced, never explained. But we have one more act, one final movement in this cosmic symphony. We must return from the abstract to the lived, from nothing to something, from philosophy to life. We must ask not just where we came from, but what it means. Not just how the universe began, but why we should care. Not just what nothing is, but what it tells us about how to live in the something we find ourselves in. The void awaits its final word, and that word is yours to speak. The end of everything is the beginning of nothing. Again, we've traced the universe from its quantum birth to its mathematical foundations, from nothing to something and back toward nothing. Now we must face what physics tells us about the end, about where all this magnificent complexity is heading, about the ultimate fate of stars and galaxies and consciousness itself. And in facing that end, we discover it's not an end at all. It's a return, a homecoming, the universe remembering what it always was beneath the temporary drama of existence. The story of the cosmos is written in the second law of thermodynamics. Entropy always increases. Order becomes disorder. Hot becomes cold. Structure dissolves into formlessness. It's not pessimism, it's mathematics. Every process that happens, every star that shines, every thought that fires through a brain, increases the total entropy of the universe. And entropy has a maximum. There's a final state where no more change is possible, where all energy has spread out evenly, where nothing can happen, because there are no differences left to drive events. This is heat death, the long, cold twilight at the end of time. Watch the future unfold across timescales that make human history disappear into insignificance. In 1 trillion years, star formation will have ended. The universe will have expanded so much that galaxies outside our local cluster will have receded beyond the cosmic horizon, carried away by dark energy at speeds faster than light. The Milky Way and Andromeda, having long since merged into a single elliptical galaxy, will be an island of light in a sea of darkness growing ever more vast and empty. In 10 trillion years, even the longest-lived stars, the red dwarfs that burn their fuel so slowly they can shine for ages beyond comprehension, will gutter and die. The universe will go dark. No new stars will form because all the hydrogen and helium will have been locked up in stellar remnants or scattered too diffusely to collapse under gravity. What remains are white dwarfs cooling toward black dwarfs, neutron stars spinning down, black holes evaporating through Hawking radiation, and time keeps flowing. In 10 to 40 years, white dwarfs and neutron stars will have decayed through quantum tunneling processes so rare we've never observed them, but which theory predicts must eventually occur. Protons themselves are probably not eternal. Given enough time, they tunnel into lighter particles and radiation. Matter dissolves. The very atoms that make up planets and asteroids and the dead hulks of stars break apart into photons and neutrinos, racing away into the void. By 10 or 100 years, a googol of years, a number so large it has no meaning in human terms, even black holes have evaporated. These were the longest-lived structures in the universe, massive black holes that formed from galaxy collisions and will persist long after everything else has faded. But Hawking radiation means they leak energy, slowly shrinking over timescales that dwarf the current age of the universe by factors beyond imagination. Eventually, even the supermassive black holes at the centers of ancient galaxies evaporate completely in a final burst of radiation. What's left? Photons, stretched by expansion to wavelengths larger than the observable universe. Neutrinos, barely interacting with anything. Perhaps some exotic particles we haven't discovered yet. All of it spreads so thinly through space that the average temperature approaches absolute zero. The universe becomes a perfect vacuum again. Not quite the quantum vacuum we started with, but close, very close. The difference between something and nothing shrinks to the purely technical. This is maximum entropy, the heat death, the state where nothing can happen, because there's nothing left to change. No gradients of temperature or pressure, no concentrations of matter or energy, no information being processed, because there are no systems complex enough to process it. The universe reaches equilibrium, and in equilibrium, time loses meaning. Change stops, cause and effect dissolve, the narrative ends. But does it? Because the quantum vacuum never rests. Even in this final state of maximum entropy, quantum fluctuations continue. Virtual particles still pop in and out of existence. The uncertainty principle still forbids perfect stillness. And given infinite time, which is exactly what heat-death provides, even the most improbable events become inevitable. Roger Penrose has shown that in an infinitely expanded, maximum entropy universe, certain types of quantum fluctuations could trigger new episodes of inflation. A random fluctuation, astronomically unlikely but given eternity guaranteed to occur, could nucleate a new Big Bang. Not a reversal of entropy, that's forbidden, but a local decrease in entropy that creates a new expanding region, a baby universe born from the corpse of the old one. Or perhaps even more radically, in a universe of maximum entropy, with all matter decayed and all energy evenly distributed, time and scale lose objective meaning. Penrose's conformal cyclic cosmology suggests that this state becomes mathematically indistinguishable from the hot, dense state of a new Big Bang. The end is the beginning. The circle closes. The universe doesn't die so much as transform, shedding its memory, resetting its clock, beginning again from nothing, and in that nothing, all that ever was still lingers, as potential. Every atom in your body was forged in the core of a star that exploded billions of years ago. Every thought you've ever had was encoded in patterns of electrochemical activity that emerged from quantum fields following laws that have existed since the universe was smaller than an atom. You are the universe looking at itself through temporary eyes, consciousness reflecting on its own existence, nothing wearing the costume of something for a brief moment, before the costume dissolves and nothing remembers what it always was. When you die, your atoms scatter. The patterns that make you dissolve. But the atoms persist for trillions of years, cycling through other forms, other lives perhaps, until eventually they too decay. And even then, the quantum fields from which they arose remain. The potential for atoms, for stars, for planets, for life, for thought. That potential never dies. It's woven into the structure of the vacuum itself, into the mathematics that governs what can be, into the nothing that is eternally pregnant with everything. This should be terrifying. The thought that everything you love, everything you've built, everything humanity has achieved will ultimately dissolve into cold darkness should fill you with existential dread. And yet there's strange peace in it, because we're not losing something we ever truly had. We are patterns in the void, brief and beautiful, meaningful precisely because we're temporary. If we lasted forever, if nothing ever changed, what would be the point? It's the impermanence that creates value, the finite duration that creates urgency, the knowledge that this moment will never come again that makes it precious. You are stardust contemplating stardust. You are nothing examining itself through the lens of something. And when the examination ends, when your particular pattern dissolves back into the general potential from which it emerged, you're not being destroyed. You're being returned to the source, reunited with the totality, becoming once again what you always were beneath the illusion of separation. Buddhism understood this thousands of years before thermodynamics gave it mathematical form. All things are impermanent. All things are without independent self. All things are dukkha, unsatisfying, because we cling to them even as they slip through our fingers like water. The path to peace is not to deny impermanence, but to accept it, to stop grasping, to recognize that you were never separate from the void to begin with. You are the void. The void is you, and the void cannot be destroyed because it was never created. The universe expands toward nothing, not as a tragedy, but as a completion. It's finishing the sentence it began 14 billion years ago. It's resolving the tension that quantum fluctuation created. It's balancing the books, ensuring that the total sum of existence remains what it always was. Zero. Positive energy and negative gravitational energy. Matter and the space-time curvature that will eventually smooth out. Information created and information erased as black holes evaporate. Everything and nothing summing to the same thing. Think about what this means for the question we started with. Why is there something rather than nothing? The answer, we now see, is that there isn't. There is nothing, has always been nothing, will always be nothing. But nothing is so rich, so full, so pregnant with possibility that it can afford to pretend to be something for a while. The universe is nothing's dream of existence, and like all dreams, it will end when the dreamer wakes. But who is the dreamer? If consciousness is fundamental, if awareness is woven into the quantum fabric, then perhaps the universe is nothing becoming aware of itself. Consciousness emerging from unconsciousness like a wave rising from the ocean. The wave is not separate from the ocean. It's the ocean doing a wave-shaped thing. And when the wave falls, the ocean remains. When the universe ends, when all complexity dissolves and entropy reaches its maximum, perhaps consciousness remains, not individual minds with their particular memories and fears and hopes, but the pure capacity for awareness itself, the nothing that can experience, waiting for the next fluctuation to give it something to experience. This is not faith. This is not wishful thinking. This is following physics to its logical conclusion and discovering that the conclusion doesn't end where we thought it did. The end of the universe is not the end of possibility. It's the restoration of maximum possibility, the return to the quantum state where all futures are equally present, where nothing has committed to being anything in particular yet. Perhaps the greatest mystery isn't how something came from nothing, but how we ever believed they were different. They're not opposites. They're not alternatives. They're different descriptions of the same thing viewed from different perspectives. Something is nothing localized, concentrated, structured into patterns complex enough to observe themselves. Nothing is something expanded, dissipated, released from the tension of structure back into pure potential. The transition from nothing to something is symmetry breaking. The transition from something to nothing is symmetry restoration. And symmetry is conserved. Never created, never destroyed, only transformed. You exist right now in the brief window between symmetry breaking and symmetry restoration. The universe has cooled enough for atoms to form, but not so much that they've all decayed. Stars still shine, planets still orbit. Life still clings to rocky surfaces orbiting medium-sized stars in unremarkable galaxies. This is the sweet spot, the Goldilocks era, the fleeting moment when complexity is possible. Before this, the universe was too hot, too dense, too chaotic for anything as intricate as life. After this, it will be too cold, too diffuse, too still for anything to happen at all. We are living in the universe's youth, its period of maximum creativity and change, and like all youth, it cannot last. The universe is middle-aged now at 14 billion years. In another 5 billion, the sun will expand into a red giant and engulf the Earth. In another trillion, star formation will cease. The timeline stretches so far beyond human comprehension that the rest is silence. Deep, cold, eternal silence. But silence is not absence. It's the space between sounds, the canvas that makes music possible. And the cosmic silence that awaits us at the end of time is not empty. It's full of potential, of quantum fluctuations, of the possibility that somewhere, somewhen, another universe will bloom from the void like we did. Eastern philosophy and modern physics converge on this truth. Form is emptiness. Emptiness is form. The Heart Sutra proclaims it. The equations confirm it. What appears solid is mostly empty space. What appears eternal is constantly changing. What appears separate is deeply interconnected. And what appears to be something is, at its foundation, nothing dancing, standing here, on a planet orbiting a star that will die, in a galaxy that will merge and fade. In a universe rushing toward heat death, you might feel insignificant. And you are, in one sense. You are a brief pattern in an incomprehensibly vast and ancient cosmos, a flicker of consciousness between two eternities of unknowing. But in another sense, you are everything. You are the universe experiencing itself. You are nothing that has temporarily forgotten what it is. You are the cosmos awakening to its own existence, if only for a moment. And that moment matters. Not because it lasts forever. Nothing does. But because it happens at all. Because against the default state of formless potential, against the vast backdrop of nothing, something occurred. Atoms bonded. Molecules complexified. Life emerged. Consciousness bloomed. Meaning was created where no meaning existed before. And the fact that it will all dissolve doesn't erase the fact that it happened. That it is happening right now. That you are here reading these words and feeling whatever you feel about your own impermanence. The galaxies will dissolve into darkness. The stars will fade. The atoms will decay. The quantum fields will return to their ground state. And in that return, nothing is lost, because nothing was ever gained. The universe will be exactly what it always was, a field of pure potential, a void pregnant with possibility, a nothing capable of becoming everything. This is not a sad story. It's a beautiful one. The universe creates beauty and complexity and consciousness, knowing that they are temporary, creating them anyway, finding them worthwhile despite their impermanence, or perhaps because of it. If stars lasted forever, if galaxies never changed, if consciousness never ended, what would be learned? What would be appreciated? What would matter? It's the ending that gives meaning to the middle. It's mortality that makes life precious. It's the fact that this moment will pass that makes it worth paying attention to. And on the cosmic scale, the same truth applies. The universe's eventual return to nothing is not a flaw in the design. It's the completion of a cycle, the resolution of a story, the answer to a question that has been unfolding since the first quantum fluctuation disturbed the primordial symmetry. We are the universe's way of experiencing the journey, from nothing to something and back to nothing again. We are the consciousness that witnesses the transformation, that feels awe at stars and wonder at existence and curiosity about origins. We are nothing's dream of being something, brief and vivid and achingly beautiful. And when the dream ends, When your personal consciousness dissolves and the cosmic consciousness dims as the universe cools toward its final state, nothing remains. Not as loss, but as presence. Not as ending, but as the eternal ground that was never not there. Nothing is what persists when everything else fades. Nothing is the Alpha and Omega, the source and destination, the canvas upon which everything is painted, and the silence that contains all sound and the darkness that makes light visible and the void that makes form meaningful. The end of everything is the beginning of nothing. And nothing, we've learned, is not the opposite of everything. It's the potential for everything, the womb and tomb of all existence, the eternal now that holds all time within it. We came from nothing. We will return to nothing. And we are, in the deepest sense, nothing still, just temporarily arranged in patterns complex enough to wonder about it. The void awaits. It has always awaited. It will always await. Patient, eternal, infinitely potential. And in that waiting lies not emptiness, but fullness. Not absence, but the presence of all that could be. Not death, but the infinite possibility of new life. This is the revelation. Nothing is not our enemy. It's our home. We've been trying to escape it, overcome it, deny it, fill it with meaning and matter and noise, but we've never left it. We are it. And recognizing that truth, accepting it, embracing it, might be the deepest wisdom available to consciousness in this or any universe. So look at the stars while they still shine. Feel the warmth of the sun while it still burns. Love the people around you while they still live. Because all of it is temporary, all of it is borrowed from the void, all of it will return to nothing. But that doesn't make it meaningless. That makes it precious. That makes it miraculous. That makes it the most extraordinary thing that has ever happened in all of cosmic history. Nothing, for a brief and glorious moment, becoming something. The final glimmer of light vanishes into absolute stillness. The last photon stretches into infinite wavelength. The quantum fluctuations continue their eternal dance, and nothing remains. Just as it always has, just as it always will, patient and eternal, and infinitely full of potential, waiting to begin again.